All right, so here we are on the 2016 10A problem number 11. It was also the 12A problem 8. While I do try to remember to label when it's also on the 12, the AMC 12, sometimes I forget. So in the first 10 of this 2016 test, there was a couple, 2 or 3, that were also on the 12 and I didn't note them. I'll probably have to refilm those later just to do with the AMC 12 test when I eventually film it. So let's get started. What is the area of the shaded region of the given 8 by 5 rectangle? Here it is, 5, 8. This is 7, but that's only up to right here. This is 1, 1, 1, and 1. How can we start? The first thing you want to do is kind of make observations, and based on those observations, start making a strategy. For example, it looks like this point right here where these two lines cross is the middle of the rectangle. Now, I don't know of any theorems that say something like, I don't know, whatever you could think of that might tell us that this definitely passes through the center of the rectangle. So we want to probably try and confirm it in a different way so we can operate on that. There's 2 ways you could do that. The first thing is, if you're not going to use your ruler right away, just to see if it goes through the middle, the diagonal is going to go through the middle, right? So if you don't want to use your ruler right away, you didn't think of using your ruler or another piece of paper, then you could do what's called chord bashing. They call it chord bashing on the AOPS forums. I'm sure it's called that elsewhere. And it's C-O-O-R-D, coordinate bashing. And you'll see me call that from time to time in my videos. It is a technique. When it's not in a coordinate plane, you turn it into a coordinate plane and use that to act accordingly. So, for example, we could find the ordered pair of this point. It's 1 from the origin, call this the origin here. So 1 from here is going to be an x-coordinate of 1, and it's got a height of 5. That wasn't hard. This point over here is x-coordinate 7, y-coordinate 0. And we know that the midpoint of this segment is on this segment. So we can take the midpoint. 7 plus 1 is 8 over 2 is 4. 5 over 2 will be the y-coordinate of the midpoint, just the average of the coordinates. Now, this is the center of the rectangle. Because the height of it is 5, half of that will be on the center, and the length of it is 8, half of that will be the center. So the midpoint of this segment is the center of the rectangle, and we can be sure if we check the other one it will also work. I'm not going to expend that time now. Now, that is not what I did on the test. When I say on the test, I take the test for fun. I don't get to submit it. But I try to subject myself to the testing conditions so I get a feel for what the students experience as they go through it. So what I did, here's the actual original test, or a copy of it. We can order them from AMC or MAA company. Just lay a piece of paper from corner to corner and you'll see that it goes through the middle. And the middle is in fact where these 2 lines meet. Okay, so now that we've made that observation, how does that benefit us? Well, if you can think of it, draw a diagonal. It will also pass through that same point. Now on the board you can't see the diagonal very well, but it's light gray on the original color. You could use a pen or even a pencil pressed darkly and you'll be able to see that line. And the benefit of it is from here, and the middle of the rectangle, you're going to create basically a triangle that looks like this. And that triangle has, if I call this the base, that will be 1. Well, what's the height? It's external to the triangle. It's going to be the distance from this center of the rectangle over to the side. Be careful not to use the 7. I assume if you do, you'll get one of the trap answers. The whole distance is 8, so this height that goes from here to here is 4. Now we have one triangle here and another one identical to it here that comes from this side with a height or base of 1, the external height again being 4. So you basically have 2 times 1/2 times base times height. And the other one's going to be 2 times 1/2 also, so I'm not going to write it to save time. And again, I only wrote it for you to share with you. If I'm solving this on a test conditions, I'm probably not going to write this 2 times 1/2, and maybe you shouldn't either. So 1 times 4 plus the other 2 triangles. Now be careful, this has a base of 1, but its height is no longer 4 because obviously it's different. It's going to be the half the height of the rectangle, which is 5, and half of it is 5 over 2. Its base is still 1. Again, it's half base times height, but we multiply by 2 because this triangle and this triangle are identical. So then it's 4 plus 2.5, that's 6.5, equivalent to 6.5. And we're on to the next one. And the next problem for this set, for the 2016 AMC 10A, is problem 12. 3 distinct. As you're reading, when you're reading keywords, emphasize them in your mind. Don't just go 3 distinct integers. Don't read so fast that you don't take the time to emphasize, right? Because that emphasis is going to help you recall it in a minute when you begin your strategic thinking of how to approach the problem. Otherwise, if you just pass over them, every single one of you knows that at some point in your test-taking preparation, you forgot a key word and you got the trap answer. It's happened, right? So take steps to make adjustments to your process, okay? So 3 distinct integers are selected at random between 1 and 2016, inclusive, meaning we can include 1 and 2016. Which of the following is a correct statement about the probability P that the product of the 3 integers is odd? Okay, so one tactic you can use, and it's up to you, I don't usually do this, but I could see myself, maybe if I was taking the test for like an actual award or for score, I might do this. Underline keywords that you think are what I call qualifying words. They qualify our answer. Are they distinct? Are they integers? Etc. We have to check that at the end to make sure we took those things into consideration. Because I guarantee if you leave one of them out, they've considered that option and made it a trap answer. In fact, we'll show how that works in a second. Okay, random between 1 and 2016. So we need a product of integers to be odd. There's 3 of them. It's kind of like heads and tails with 3 outcomes. A good idea is just to list them. We're on problem 12. We're making some good progress at this point, assuming you got the first 11 correct. You're getting closer and closer to qualifying. We can't afford to get anything wrong. Take the time. It doesn't take long to list it out. Here are the options. Even, 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 odd. Now you could keep listing, but maybe as you're writing, before we continue, analyze. This is going to be an even result. Even times even times even. In fact, any time there's an even in one of the 3 numbers, you're going to get an even result because an even times an odd is even also. Why is that? Because every even has a factor of 2, and when you're multiplying, that factor of 2 will not go away. Therefore, the end will still have a factor of 2 and therefore be even. Well, we could write them all down if we wanted to, and if you did, no harm, no foul, right? But if you can notice that, you can just see that the only one that's going to work is ooh, or actually it's o, or odd, 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 right? So 3 odds, the product of any number of odds will be odd. This is the only case of the 8 cases. How do you know there's 8 cases? Because there's 2 choices, 2 to the third, 2 for the first choice, 2 for the second choice, 2 for the third choice, right? So 2 to the third is 8. So then these are the 8 outcomes if you took the time to list the other ones. They correspond with combinations, by the way. You should explore this on your own. You might see me talk about it in a different video. This is 3 choose 0 to be odd. This is 3 choose 1 to be odd. It could be here or here, giving you 3 ways, and so on. That's a very important connection to make. I hope you've already made it by this point in your instruction. Okay, so there's 8 outcomes. This is the only one that's going to give 3 odd integers. So what is the chance of this happening? Well, let's say for a second that they weren't distinct, right? Let's just say they weren't, because it actually makes it easier to think about. If they weren't distinct, you can see there's an equal number of evens and an equal number of odds. 1,008 evens, 1,008 odds. The number of them doesn't really matter, just the fact that they're equal, right? So the chance of your first draw being an odd is 1 out of 2. Now, if you could pick a second number and it could be equal to the first number, then each choice would be 1 out of 2 because you'll still have an equal number of odds and evens at every selection. Now, if you multiply this, you get 1/8. And in fact, I'm willing to bet this is probably the number 1 trap answer on there. Meaning if you look back at the results and the statistics, I bet if people got it wrong, this is the most likely wrong answer. And the reason is we stopped thinking about distinct and we put this, and the test makers know that people are going to do that. So because they know people are going to do that, they put P equals 1/8, and you feel so happy. You're like, I got this. I'm so good. You put B, circle it, whatever, shade it in, and you get your test back. What? I forgot to, yeah, it happens all the time. That's why you've got to be extra careful and vigilant when you're reading the words not to do that. And maybe take a few seconds to check at the end, does this jive with what we did? Go back and look at the underlined words if you underlined. Are they all distinct? No, they're not. Right? We assumed you could have the same number chosen, but in fact, after the first pick, there is one less odd but the same number of evens, which means the chance of getting an odd is less than 1/2 now. We don't actually care what it is. We just know it's less than 1/2. I mean, yeah, you could calculate it. It isn't hard to come up with the actual numbers, but that's a waste of time in my opinion. You can just say, this is actually less than 1/2, and this is some number less than 1/2. So when I multiply the 3, I don't actually get 1/8, right? I'm going to get something less than 1/8. The probability is less than 1/8. This is the only answer that has that in it. Therefore, we don't need to think about the rest of these, right? So the answer is going to be A. Furthermore, sometimes it's a strategy to look at the answers to help you understand. In fact, sometimes you have to use the answers to determine which of them is correct. But most of the time, you probably shouldn't do that. You should get your own answer and then confirm it in the answers. Okay, on to the next one. All right, and on to the 2016 10A problem 13, which was the 12A problem 10. If you're watching the whole video through in the last problem, I know the video glitched for like 2 seconds in the middle of my speech. I don't want to refilm the video. There was too many emphasis on points and things like that I don't want to repeat. I don't think it interferes with understanding what I was saying, but I apologize for it happening. Okay, 5 friends sat in a movie theater in a row containing 5 seats, numbered 1 to 5 from left to right. So kind of process as you go. As usual, 1, 2, 3, 4, 5 lines, label them 1 through 5. Now it says that during the movie, Ada went to the lobby to get some popcorn. When she returned, she found that Bea had moved 2 seats to the right, CC had moved 1 seat to the left, and D and E had switched seats. You'll notice as I'm reading, at some times I'll just stop calling them by their names because we don't really care what their names are. They're fictitious. So we just need to know their letters, A, B, C, D, and E, which are made that way on purpose precisely so you can do that with your processing. Okay? So A went to the lobby, B goes 2 seats to the right. We need to write some symbols to represent what we read. Don't just read because you're not going to remember everything. Write something that indicates what logical thing happened and use symbols to indicate it so we don't have to go back and read every single sentence when we're processing later. CC, or just C, had moved 1 seat to the left, so C is going to go this way 1, and it says D and E switch seats. So you can put 2 arrows, 1 going either way. Oops. Okay, so D and E switch seats, leaving an end seat for Ada. In which seat had Ada been sitting before she got up? So you might not know how to approach this problem. It's not a standard math problem. It's more of a logical reasoning. But the longer that you sit and analyze and think, what's the best approach? Can I even think of one? That's time wasted. I kind of feel like, this is my opinion, you should just kind of get started. So what can we say? If B moves 2 to the right, then B could not have been in seat 4 or 5. So B would have to start in one of these seats. Likewise, since C goes 1 to the left, C cannot be in seat 1 or they'll be in the aisle or wherever that is. So they can be in one of these 4 seats. You can see there's 4 C's here, but did you foresee that okay, never mind. I'm sorry about that. All right, anyways, so B goes 2 to the right, C goes 1 to the left, D and E switch spots. What you can do, if you're not sure how to start, just kind of make an if-then, right? What if B was in this seat? Because it's one of the 3 seats B could be in to start, right? Then B will end up in this seat, right? And then you could say, all right, if B was there, what about C? Let's put C next to B so C ends up in B's seat. Now, D and E cannot be in these 2 seats because they essentially occupy the same seats, just different positions, but nobody who was in D or E's seat, nobody else can be in their seats but D and E at the end. So D and E cannot be in these seats, nor can they be in these seats. That means D and E would have to be here and here. E would have to go here. That means A was here and ends up here. And you might go, oh, it's seat 4, we got it. Yeah, it works except for the fact it says that Ada got an end seat at the end after she came back. That's not an end seat, so Ada's not there. Okay, but even though we did something like that and it wasn't fruitful, don't worry about that. It's now a model that we've used to understand the nuance of the problem at a deeper level, and maybe we can come up with a better strategy. So based on what we did, let's focus on where we want eta to be. I'm not even going to label the seats. There are only 5 seats. We don't need to do so. So eta needs to end up in a end seat. So in the then one, let's put eta here. And we could try over here too. And in fact, if this doesn't work, that's what we'll try next. Now, in order for eta to end up in the seat, somebody else had to be in it in the if portion. We already know it could not have been C, nor can it be D and E. That means it must be B. It has to be B. That's not a joke, actually. So B to the right, 2 spots will end up here. Now, who could be in B has to end up in the seat. That means somebody else must have been here originally. Could it have been A? We don't know yet. We know it couldn't have been D or E in either of these 2 seats because that won't work out. So what about C? C has to go 1 to the left. Let's try C in this seat and see what happens. This sounds totally unintentional. So C goes to the left, and that would end up here, and that leaves these 2 seats for D and E to do their seat swapping. And I don't know why they would do that. One of the thoughts I had while reading this is they're probably teenagers, because can you imagine like 20, 30, 40 something switching seats in the middle of the movie? I also have random thoughts like, what's up with Ada going to get popcorn? You're watching a great movie. Oh, I think I'll leave in the middle of it and get some popcorn and miss the key scenes. No one's doing that. She must not have liked the movie. Who knows what it was? Okay, I mean, fictitious and all. So A ends up here. That means A could have been in the seat. Now, does this violate any of the things that we were told? Did B move 2 to the right? Yes. Did C move 1 to the left? Yes. Did D and E switch spots? Yes. Then this works. And we don't really need to check other answers to know that A was in seat 2 at the beginning. The reason we don't need to check, well, as long as we are very confident, I'm very confident that we didn't violate any of the things that we said must happen, and I'm 100% confident in that, we don't need to check other scenarios. Because even if there was another scenario that worked, it's still going to have A in this seat. Otherwise, there'll be 2 answers and the question would become invalid. So it must be that A is going to end up in this seat. If A was to end up in this seat, again, you probably have to figure that out. I think if you check it, and you probably should, explore it on your own, not during the test, and you'll see that it's not going to actually work out. So we know that A was in seat 2. That's the end of the problem. We're on to the next one. All right, and here we are in the 2016 10A problem 14. How many ways are there to write 2016 as the sum of 2's and 3's? Ignoring order. For example, 1008 times 2 plus 0 times 3. Just quick check. 2016 plus 0 is 2016. And that one's going to work also. Are 2 such ways. Them giving this example, it almost makes the problem trivial, especially this one, because it's really going to kind of help us out in our processing. What we're saying is basically 2A plus 3B needs to equal 2016, where A is the number of 2's and B the number of 3's. So let's kind of start a t-chart, and we'll use this one because it's at the extreme. It's the most number of A's. Wait, can you have negative values? No, because it's sum of 2's and 3's. So 1008 and B would be 0 for that scenario. Now, that also gives us an idea of where we're going to end. Is 2016 divisible by 3? Yes, because the sum of the digits is 9, and that's divisible by 3. You might know from previous problems that 3 times 67 is 201. A quick check mentally will tell you that's true. That means 3 times 670 is 2010. By previous problems, I mean in previous years that calculation has come up, and maybe you're like me and remember weird calculations. Then how far away is 2010 from 2016? It's 6 away, or 2 multiples of 3. So 672, adding 2 to the 670, right? Because 3 times 2 would give 6, and the sum of these 2 is what we want. 672 with a 0 here. Okay, then what's the next one after this if I was to march this direction with the fewest the changes to B, or that are allowed? Well, think about it. Every 3 multiples of A is 2 multiples of B. So if B is going to go up by something, it must go up by 2 to give 6 now as the value for this expression. And if this is going to go up by 6 from 0, then this is going to go down by 6, which must mean A goes down by 3 values to 1005. And this process is going to continue until it gets to here, right? Basically adding 2 and subtracting 3 over and over and over again. We could list it all out. That would take forever, so we don't want to do that. So what you want to do is take this number, 672, and subtract 0. The formula that we're using is actually b minus a, not this b and a. I shouldn't use the same letters, but it's too late now. B minus a over the common difference plus 1. Okay? So if you're counting by, I don't know, sevens, right? So let's say you have 14, 21, 28, and you want to know how many multiples of 7 you have. The b would be 28, the 14 would be a, so you would have 28 minus 14 divided by what you're counting by, the common difference, which is 7, and then you add 1. 14 over 7 is 2, plus 1 is 3. This is just a check so you can understand how that formula is applied. And so we're going to apply it here. 672 minus 0 is 672. And the common difference for us, we're counting by 2's. So it's going to be 336. Be careful, don't forget the plus 1. The plus 1 gives 337 because if you forgot the plus 1, the wonderful test makers accounted for that. And they're going to love it when you chew. They won't really love it, but I imagine them gleefully being, ha, I got that kid. Right? Don't let that happen. Get the plus 1 in there. Get 337. Get it right. Win a prize. We're done. All right, and now the final problem of this set, the 2016 10A problem 15. By this set, I mean problems 11 through 15. 7 cookies of radius 1 inch. Pause, look at the picture. What are they talking about? 1, 2, 3, 4, 5, 6, 7. Okay, it's these 7 circles in the middle. They're each radius 1. Are cut from a circle of cookie dough, yum, as shown. Neighboring cookies, that's all of these neighboring cookies, are tangent, meaning they touch in one point to the adjacent cookie. And all except the center cookie are tangent to the edge of the dough. The leftover scrap is reshaped to form another cookie, bonus, of the same thickness. What is the radius in inches of the scrap cookie? Okay, the same thickness, why are they telling us that? So that you know it's not like, it has to be higher than the original cookies, it's the same height, so we can kind of just disregard the thickness altogether for the rest of the problem. So how do you approach this? Usually with circles, you kind of want to connect their centers. So if we take, say, this one here and connect to here, that doesn't really do a whole lot. We could also make an equilateral triangle connecting that one, but maybe by drawing that, it gives you the idea, because we need to find the radius of the big circle, right? That way we can find the area of the whole dough, all the dough, and then subtract the part we don't want to get the area of the scrap. Okay, so then if that's the goal, we need pi big R squared minus 7 times pi little r squared. Don't forget the pi. So pi r squared minus 7 times pi little r squared. Big R, little r are traditionally used for big circle and little circle. It's just how it works usually. So we need the big radius. We know the small radius is 1. So this is going to be pi big R squared minus 7 pi. Okay, well, what can we do? We need the diameter or the radius, and if you look, the edge of this cookie is tangent here. If I just continue right through that line segment, voila, we have the diameter of the big cookie. And it's actually 3 diameters of the small cookies. Be extra careful right here that you don't think that's 1 plus 1 plus 1 is 3 for the big diameter. No, it's not. The radius of the small cookie is 1. So 1 and 1 is 2, 2, 2 and 2 is 6. So again, be careful still. Make sure you're extra checking your thinking extra. I don't know. So being vigilant in your thoughts. Okay, so the diameter is 6. You can sense you're on the home path right now. I hope you can. You're rounding third, heading for home. It's easy to trip up at that point and cost your team a run, which is you're your team. So we don't want to do that. So kind of write things down, slow it down a little bit. Don't speed up too quickly. If the diameter is 6, if you hold it in your head and just go 6, you might put that 6 in here. But if you write it on paper, you're probably not going to do that. Cut the diameter in half to get the big radius, which is going to be 3. Plug that 3 into the big R, square it to get 9. 9 pi minus 7 pi. That is our scrap dough. Our scrap dough has an area of 2 pi, and we're going to call it r again, even though it's not that r. If you want to put a little 2 here, feel free. Pi r2 squared is going to equal 2 pi. Divide by pi to get rid of those. We need this radius of the small cookie, right? What is the radius in inches of the scrap cookie? Also, pause for a second. Wait, are they trying to trick us? Was it inches in the beginning? Yes, 1 inch. Okay, they're not trying to trick us. Thank gosh. You know, one of the few times they're not trying to trick us. So we want to square root this, and you're going to get, I don't even have to write it. It's the square root of 2. All right, we will see you in the next set of videos. Enjoy your night.